All right, frequently in calculus, you're asked to draw graphs of various things. And one of the techniques that really helps make that an easier task is to understand what different transformations do to a parent function. So the point behind this section is to look at some specific positions in a general transformation. So let me kind of highlight this general equation. There's only so many things we can do to change an equation, and we're going to focus our efforts on four positions and look at what happens if we change just the number in front of the function versus just the number at the end or somewhere in the middle. What happens if you add or subtract, or if it's negative, or if you're, things like that. And our goal is to be able to look at an equation, figure out what its parent graph is, and then decide what kinds of transformations are affecting the overall picture. Okay. And so the first thing we're going to isolate out is that number out front. So we're going to compare it to a quadratic. So let's say we look at y equals x squared versus y equals, some other number x squared. And I'm going to use sort of a computer program to kind of speed up this connection we're making about the different transformations. So let me kind of get this pulled up here. Okay, so what happens if I change that number out front and I make it larger? Okay, now what did you notice happened to the graph? The graph got skinnier, got, what we would call a narrower equation. What's actually happening here is the y values are getting bigger in the blue one. And that's what that particular transformation is. So on your paper, I can pull this up, you can kind of describe to yourself what you notice the actual graph is doing. Let me go the other direction where we actually make it smaller. And again, I'm not interested in negatives at this point. I just want to notice what happens as I drag it along. And if you look, made it negative, so I kind of got ahead. If you look, it actually ends up making a wider looking graph, and that's because the y values themselves are actually smaller. And then the third thing we want to look at is what happens if we make it negative, and you got a small taste of that. So as I make it negative, that actually reflects it below the x-axis. Okay. Okay. So just a quick summary or comparison. So I'm going to make the parent graph be red, and I'll make the other guy be blue. So if it's the number out front is something bigger, then we would expect it to be inside the original function. If the number, in fact, was, so again, the red one is the parent graph, and the blue one is the transformation one. In this case, we would expect it to be a wider graph than the original parent. And in the third case, and I'm going to need more room on that. Okay, so again, the red is the parent, and the blue is the transformed one. So if there's a negative, the negative simply reflects it down below the x-axis. The next set of transformations we're going to look at is inside the function. So what if we're manipulating this b term, changing it to either something bigger than 1, something smaller than 1, or just a negative? What physically does that do to the graph? And again, I'll pull up the little computer program here. And I'm going to change that position. Again, I'm going to make it bigger. So notice what happens as we make it bigger. It appears that we have sort of made the y values bigger, doesn't it? In fact, we did what's called a horizontal compression. So the x's tended to shrink on us. Consequently, that makes the y's look bigger. But it's easy to get those two things confused. Go the other direction. So again, as I make x get smaller, not negatives necessarily, but just something smaller than 1, we do notice a similar type transformation from the vertical, but again, we're looking in terms of horizontally. So the x values actually got bigger, which consequently made the y values get smaller. And then as I go negative, now this one's kind of hard to see on a quadratic. I'll try. you probably won't see anything significant happening. You probably didn't even see it. Let me switch to a cubic function, and that one's a little bit easier to see what happened. So as I made that middle term negative, that actually reflected it across the y-axis. And essentially all the x's switched places. So what was positive x is now a negative x, and a negative x is now a positive x. Okay. So what do we write down that'll help us remember this? Okay. So let me kind of compare. Again, I'll kind of compare that to the parent here. So I'm going to stick with red being the quadratic. So as our inner term got larger, we noticed that same sort of shrinking inside compared to when it was a fraction or somewhere between 0 and 1. It tended to get wider. Okay. And if, and then again, this one I'm going to switch to illustrating this on a cubic because I think that helped a little bit better. Ended up being a reflection across the y-axis. Okay, the next set of transformations we're going to look at is what if we're adding and subtracting? We're going to start with inside the function. So what if this term we're adding is add or subtract on the inside? So let me go back to here. And this time I'm going to take this and add a constant. Now notice what happened. I don't know if you guys can see this. Let me see if I can make it a little bit bigger. There we go. So as the number increased, it actually says x minus 3.4. So as I subtracted a larger number, it actually moved the entire graph to the side, but in the positive direction. Now, to me, that sounds opposite of what we think it should be, and that's actually correct. If I make the number a larger negative, that moves it into a larger positive. And just to kind of show you that the opposite is true, as I make it a bigger negative, it moves it in the same direction as in the negative direction, though. So even though the equation says I moved it 3.3, I moved it negative 3.3 in the x direction. Okay, so going back over to our notes, what does that do? So again, I'll do sort of the red is the parent function. And I'll do blue as the transformed. So as I get larger and larger, plus c, that actually moves it sideways in the negative direction. But as I subtract it, it actually moves it in the positive direction. Okay. And then the last thing we'll kind of address, and then we'll look at some practice problems, is moving it up. Okay, so I'm going to change that last position. So as I make them larger positive, what happens? It moves everything up. And that matches what we think it should be. Is as I get larger positive values, all the y values go up that same amount. And as I move it down, then the y values go down that same amount. Going back over to our note sheet. Okay, what that tells us, and again I'm going to use the red for the parent. If I add a constant, that shifts everything up that unit, and if I subtract, that shifts everything down, and it just changes the y values in the picture.